Okay, we've already talked about arithmetic sequences, and then we just finished arithmetic series. So the next thing we're going to move to is geometric sequence. And just like with the arithmetic sequence, a sequence is just the series of numbers, the list of numbers, excuse me. Series is a poor choice of words, but it's a list of numbers as we go through there. So we're going to try to find a specific number. We're not going to add those up as we go. Remember, that's called a series. Let's first by talking about the definitions of these things. A geometric sequence is a sequence in which the ratio of consecutive terms is consistent. All right, keyword is ratio. And that constant is called the common ratio, and it's denoted with the letter R. That is a italicized R. So with arithmetic, we were adding or subtracting to find the terms, and in geometric, what we're going to be finding is that it has a common ratio, a common multiplication or division. And technically, division is multiplication by a fraction. All right, so the way we find this is all we need to do is take the term, any two terms in the sequence, a sub 2 minus, or not minus, a sub 2 divided by a sub 1 is usually a really good place to look. But regardless of which one we choose, if I say a sub 4, then it needs to be divided by a sub 3. Well, whatever we choose to do, we should see a common ratio between these values. You may recognize the pattern on some of these, and that's perfectly fine if you recognize the pattern, but it's also very important that we are able to find the ratio when there is not a specific pattern as we look. So as we look at these terms right here, you may look at this and notice, okay, I see that that is a times 3 times 3 times 3 times 3. But if you don't see that pattern, all we've got to do is take the a sub 2 in this case that is 9, divided by the term in front of it, that is 3. So 9 divided by 3 is 3. This is true of any number, consecutive numbers in this sequence. So 81 divided by 27, also 3. 27 divided by 9, also 3, so on and so forth. We just have to take the two consecutive terms. So in this one, what it tells us, determine whether it is arithmetic or geometric. Well, this one is clearly geometric because it has a common ratio. And that common ratio, we denote that with an R. The common ratio of this is positive 3. The number was increasing. All right, as we take a look at question number 2, we see that we go from 1 to negative 2. That would be minus 3. And then the next thing, we're back in the positive numbers again. And if you recall when we first started talking about this, when you jump back and forth from between negative and positive, what you have is a common ratio that involves a negative number. But again, all we need to do to find this is take any consecutive terms. Negative 2 divided by 1 is negative 2. I'm going to jump all the way to the end. 16 divided by negative 8, also negative 2. If any of these do not have a consistent ratio, then it is not geometric. But this one, in fact, is geometric. I don't see any contradictions because 4 divided by 2 is also 2. 8 divided by 4 is 2. So we do have a geometric ratio, geometric sequence, excuse me, and the common ratio in this case is negative 2. All right, as we move to letter C here, we see we go from 4 to 9. That would be an addition of 5. And then we go from 9 to 16, excuse me, that's an addition of 7. So this is clearly not a arithmetic sequence. So we're going to check to see if it's a geometric sequence. And we would take 9 divided by 4. Now, we can leave it as a fraction, or we can change it into a decimal. The decimal for 9 divided by 4 is 2.25. And I can go to anywhere on this thing. I'm going to just go ahead and jump to the next one, which is 16 divided by 9. 16 divided by 9, if it's anything other than 2.25, which it is, it's 1.78 repeated. So this is not equal to that. So what I learn is this is neither geometric or arithmetic sequence. So this is neither. In fact, what it is it is quadratic, but that's not what we're dealing with right now. We're only dealing with arithmetic and geometric. And then we see we are going from 25 down to 20, 20 down to 15, to 10, to 5. So this is very clearly a subtraction of 5, so it's an arithmetic sequence. And that has a common difference, the common difference being -5. So we've touched on most of this already. We're just actually going to put it into practice. You might want to notice your math tip over here to the right. Our math tip does say to find the common difference. This is what we talked about. You subtract the term by the preceding term. To find the common ratio, you divide term by that. So that's in our math tips over there to the right. Now, if you remember when we started talking about arithmetic, what I told you at the beginning was the key thing is that explicit formula. That is also going to ring true here when we talk about geometric. So go ahead and write this down. This is the geometric explicit formula. It's very important we get this, and it's also very important we know what everything means. A sub n means the number we're interested in. A sub 1 means the same thing as it did in arithmetic. It's the first term in the sequence. R is our common ratio. And then, of course, our n is the number of interest again. So if we're looking for the 15th term, n would be 15. And then highlight again here, n minus 1, because remember, it is a sequence. And on a sequence, what we have to do is we start at 1, not 0. So this is going to regulate that for us. So notice you got to jump back and forth, and you got to be ready for this. We're jumping back and forth from a series to now a sequence. And they're using the letter A as opposed to the letter S. So we are not going to be adding these up as we go. Now, you could just continue the pattern that you see. So this is a times 2 pattern, times 2, times 2, times 2. And we are currently sitting at A sub 1, 2, 3, 4, 5. So, I mean, you could do that another 11 times and figure out where we're at. But let's just get practice using this formula, because if it was a 76th term, the last thing you want to do is to double a number 76 times. So what we're looking for is A sub 16. We're going to put this into our formula. Our formula is, and you'll hear me call this a base sum, because we will start talking about exponents before too long. But our A sub 1 value, A sub 1 is 1, because we actually started our pattern at a 1. Our ratio, the number is doubling here. And again, if you get confused, remember, just divide. And that would be our base value, which is 2. And then our exponent is going to be 16 minus 1. And we are plugging this in. Remember, on summations, we didn't plug in an n value because we weren't just looking for the n value. We were looking for the first 1 through the n value. So we're going to leave that just like that. I'm taking this to my calculator. Remember, the button above the division sign is our power button. So I type this in my calculator, plug in 16 on this, and what I learned from my calculator is A sub 16 is 32,768. If you're ever uncertain about your formula, Plug in one of the ones you know. Like we know a sub 3 is 4. So if you're ever unsure about your formula, take the formula and put it in and put in one of the values you know. We know that 3 is supposed to come out to 4. I put it in my calculator and it does. So you can always check your formula because you have 5 answers to check it on right there on the right, or left, excuse me. And then lastly, we will deal with geometric transformations that we'll later learn, we'll call this shrinking. This value is shrinking. We go from 4,000 to 96 to 1,024 to 256 to 64. Now, we may not know that ratio right off the top of our head, but that's why we take it to our calculator. Divide your consecutive terms. Excuse me, did that backwards. I about made the common mistake that you want to avoid, which is a lot of people just think, well, I'm going to divide the bigger number by the smaller number. That's not what we do. We divide the number on the right by the number on the left. So we're going to take 1,024 and divide it by 4,096, which is 1/4. I'm going to test a few more of these. 256 divided by 1,024. Technically, I should check all of these values, because if only one of those is off, it messes up the whole thing. This is 1/4. Then we would do 64 divided by 256. Put that in your calculator, you also get 1/4. So what we learned from all of that is the common ratio for this is 1/4. These values are getting cut in 1/4 every step of the way. We are sitting at a sub 4, and we need to get to a sub 9. So we got to cut in fourths 5 more times. But again, let's trust our formula. Let's get good at this. The formula a sub 9 is equal to a sub 1, our starting amount, which is 4,096, times our common ratio. Make sure you use a parentheses here. Our common ratio is 1/4. Our common ratio is 1/4. It's getting cut in by 1/4 each step of the way, and we have to regulate this with an n minus 1. But n is no longer unknown because they told us we are interested in the 9th term in the sequence, so I'm going to replace my n with the number 9. And I'm going to just take this value to my calculator. 4,096 times 1/4 to the 8 power. You can do that work in your head. You can type that in your calculator as well. 9 minus 1 is a pretty easy number to do. Now let's talk about a couple of things here. What my calculator tells me is a sub 9 equals 0.0625. 0.0625. And if I want that in fraction form, remember we can put things in fraction form by simply hitting math, the math button, enter, enter. And if there is a fraction form for this value, it will change it for us, and it does. It has a fraction value of 1/16. So this is geometric sequence. This is where we're just pinpointing one number out of the list. We are not adding these up like we were doing with the arithmetic. We are just picking the, in this case, 9th term in the sequence. And the last one, we were picking out the 16th term in the sequence. And just be careful because these do get very large and very small very quickly.